So India Smart, just a couple of lines about my organization. I work with India Smart Grid Forum. It's a PPP initiative of Government of India and was established to accelerate development of smart grid technologies and deployment of e-mobility in India. And we work with national, international agencies to develop the right standards for the country and help the utility regulators and the industry in strategy development, technology selection, training, and capacity building. So with that, today, as part of this training program, I would be talking about the intelligent buildings for power system flexibility. The buildings, as we know, drive up to 70 to 80%, as all my colleagues have already iterated, during the peak demand on the grid, and thus they are responsible for they are key to balancing the grid. And if your building could communicate with the electric grid to save your money and lower your carbon footprint, we will all would be intrigued and would want to explore how. And every second of every day, the grid completes one-way transactions with our home, offices, the commercial stores, malls, and every building in between to supply electricity. And supplementing these one-way transactions with a two-way dialogue, and that allows for timely two-way transactions and empowers the buildings to help the grid balance electricity supply with demand. And this can drive immense cost savings and carbon reductions, plus increase reliability and resiliency, all without impacting the day-to-day operations of the building. And the buildings can accomplish this today with using existing technologies. A lot has been discussed already about the solutions. I'll also be, talking about some of them that India is working towards. But to achieve a truly grid interactive future, we need better controls, integrations, and interoperability in our buildings, a strong communication and pricing scheme between utility and building operators, a new paradigm management that focuses on when we use energy rather than just how much energy we use. And a lot has been covered about flexibility and what makes a building intelligent, and to provide support to power system flexibility. And I'll be covering the topic from India perspective, the scenario in India, and why and how this resource can play a key role in bringing.
Sorry to interrupt. Your slides are not moving. You're still stuck on the cover slide.
Yeah, I've just, this is my introduction bit. So
sorry, no problem. Then some people, including me, were getting worried that there might be a technical problem. Sorry for an interruption.
So just last line on before I move on to my first slide, that I'll be covering, the Indian scenario, and also how building as a resource can play a key role in bringing the required flexibility that we are looking for, not only for the India grid, but worldwide. So few things I want to talk about the India grid, just to give a perspective, and I'm sure most of the ASEAN countries have a similar scenario. India has the third largest power system in the world, and with 5 regional grids having separate modern control centers, 1 national control center, and each state in India has its own state load dispatch centers. And we also, with the renewable energy injections coming up, we have created renewable energy monitoring centers in different parts of India, which are sophisticated tools for processing weather forecasting from external systems to forecast and estimate renewable energy generation. And our transmission systems are highly modernized and operates on 800 kV and 500 kV high voltage direct current lines. We have wide area monitoring systems in place, and phasor management units are installed in the transmission grid. Also, we have a generation capacity of 405 gigawatt, but our per capita consumption remains to only 1200 kilowatt hour per person per year, which is 1/3 of the world average that is seen. We have, every state has multiple distribution companies. Most of them are government owned, and a few, say about 10 are privately owned. The overall power management is regulated by the state regulatory commissions, as is there in most of the countries, and we have a regulator at the center and a regulator for each state regulating and mandating the policies for the state. 300 million consumers are already connected to the electricity grid, so you can imagine the volume of consumers that are demanding power from the grid, and our grid is covering 3 million square kilometers. India is a large country, and it's operating on one frequency right now, which is a great achievement by the Indian power grid operators. And India has surplus power generation capita, but lacks adequate infrastructure for supplying electricity to all who need it. And so in order to address that, our government had launched a very ambitious program in March 2019 with that, which is called Power for All. And with that, we were able to, in a record period, we were able to connect 26.3 million more households in the rural area, electrifying, and electrified them in around 17 months, which is a world record that we had. And India is the fastest growing market in the world, and Indian power systems are expected to double by end of this decade. So, looking at the overall scenario, we are moving towards adopting many technologies and, setting targets for Indian power sector. We have, government has set a target of installing 250 million smart meters in the next 5 to 7 years, connecting most of the consumers to the grid and have two-way transmissions. For decarbonization of power systems, the RE target that we had set for 2022 was 175 gigawatt. And by November 21, we have already achieved 150 gigawatt of renewables, getting injected to the grid, and a target of very ambitious target of by 2030 to have 500 gigawatt of renewables, additional renewables getting connected to the grid. We are also working towards decarbonization of transport sector, the transformative mobility, and also have, we have a mission called Transformative Mobility and Energy Storage Mission, which with the, very ambitious targets at a national level that we have put off. We're looking at introduction of 6 to 7 million electric vehicles in the next 5 years. And also our government is also looking on, where some of the participants talked about standards. So we are continuously working on having the right standards. We already have a smart meter standard in place. We are currently working on having the standard for EV charging infrastructure. Many initiatives also have been undertaken to make for making the power grid smarter, like having a smart grid vision roadmap, having a lot of smart grid pilots in place. National mission, smart grid mission, has been established, and we have also put together an energy storage roadmap for India for the period 2019-2032. ISG have worked with the government on that, and estimated that by 2032 we will have 2,416 gigawatt hour of which 209 gigawatt hour is will be grid support of the battery storage system that we are looking for. And many digital technologies we are playing a crucial role in integration of all these different systems that we are bringing in, and disruptions that we are bringing in to stabilize the grid operations. Indian power utilities are also looking at to leverage these emerging technologies such as artificial intelligence, machine learning, advanced analytics, blockchain, which was just presented, and augmented reality, drones, and so on and so forth. So Indian power systems need, it was estimated by International Energy Agency, it was projected that would all, Indian power system and its capacity is estimated to be more than double by 2030 to about 823 gigawatt and reach 1,584 gigawatt by 2040. And out of this 1584 gigawatt, about 841 gigawatt is expected to come from solar, wind, the green energy solutions. So hence the power system requires about 85% flexibility, which is the highest such requirements in the world. And no other power system is expected to be more than 50% flexible. And therefore, there is a dire need to build a good demand side flexibility, power plant flexibility, energy storage system flexibility. The grid flexibility policies have to be in place. We have to look at market and regulatory solutions for short term to medium term to be able to manage this kind of flexibility that is required by the system. What is power system flexibility? I mean, my colleagues have already talked about some bit of it, but I would like to give my perspective for that. Theoretically, an electric power system, it must balance generation and demand in real time. And in every cycle, 1/50th or 1/60th of a second, as the case may be. And in the past, the system operators had full control on the generation resource, though they did not have control on the load that the customer premises will be, intaking. Hence, the spinning reserves of about 5 to 10% were kept and were provisioned to balance the changes in generation and load. But today, with the proliferation of variable renewable energy sources on the grid, the system operators have neither full control on the generation resources nor on the load, at the customer end. So thus, there is a dire need for having the power systems flexibility solutions in place. And to be able to manage a power system with unpredictable generation sources and load at customer premises, it is essential to have both have control on both generation and load through automated control systems or the flexibility in the power system. So thus, there is a need for power system, bringing the power system flexibility with different solutions. Again, I would like to just reiterate a couple of points which makes it mandatory that we bring all the solutions to be able to have the right power system flexibilities for the grid, starting with the, to be able to accommodate the heavy penetration of renewables, particularly when I talked about Indian scenario. We have, going forward, we are talking about 450 to 500 gigawatt by 2030. And the renewable energy injections into the grid, such as maybe wind, solar, or the other sources, they can create a lot of inflexibility and harmonics can be generated. So we need a lot of flexibility with these unpredictable sources getting injected into the grid. And without sufficient flexibility, system operators may need to frequently curtail, decrease the output of wind, solar generation. And although, the low levels of curtailment, for example, less than 3%, may be a cost-effective source of flexibility. Still, significant amount of curtailment can degrade the project revenues of renewable generators and the contract values and impact the investors' confidence in the renewable energy revenues and make it more difficult to meet the emission targets also for that have been set. So it's very important to have a system which can manage the load, which can forecast the load and be able to manage the grid better. And also, addressing the contingencies related to the network issues, like our transmission networks with the limited bottlenecks and sufficient capacity to access a broad range of balancing resources, including sharing between neighboring power systems and with the smart network technologies that better optimize transmission usage. This is required as at a time when there are transmission bottlenecks within the network of one state, as well as, due to limited capacity of the interstate transmission lines. And going forward, mitigation of power quality issues, is one of the very important issue that needs to be addressed with the systems, like such as harmonic surges, frequency and voltage fluctuations, are something which we need to address. Now, it is also required to manage the variable load due to, manage the load due to the variability in the usage pattern of the consumers, like be it the residential, commercial, or industrial customers. Also, due to, there's some weather or calamity events, there's some festival events when there is more demand or less demand. So this is something also that is one of the key issues that needs to be addressed. And some of the solutions that we have worked upon and are testing out are like demand response and time of use, time of day tariff, which can help meeting the demand flexibility, shifting the load when there is a peak demand. And also issues like frequent outage of conventional power plant is something we need to address, like electrical, mechanical default. So these are some of the issues that raises a huge requirement for the need for power system flexibility. So what are the sources? I won't go into the detail of this, as Pauline and other speakers have already talked about, but just want to stress upon a few which India has been experimenting with, and they are something which which are the key we have identified. So the flexibility of the power systems that can be achieved through a combination of these systems, and I mentioned demand response and other demand management systems, the grid integration of distributed generation resources, including behind the meter sources or customer premises. Electric vehicles is one of the source, and grid integrated energy management systems we have talked about. So flexible generation resources such as hydroelectric plants, quick start gas turbines, thermal power plants, that can be modified to operate as a flexible plants whenever the demand is high or low, it can be utilized. And energy storage system is also something is a key across the country, and sustainable business models around it are something we are working on, such as having battery energy storage systems at solar and wind farms, pumped storage hydro plants, other energy storage systems is something we are also working on. Replacement of polluting diesel gensets with the battery energy storage. This is something just wanted to mention that we are also looking at, just to reduce the emissions and meet our NDC targets. And district cooling systems with thermal storage is one of the solutions that will bring a lot of benefit to the grid. And retrofitting the hydropower plants with pump storage is going to be very beneficial. And we have already talked about demand response, time of use tariff to manage the peak load with shifting of load by the customer. And also talking about electric grid integration and aggregation of EVs connected to the grid as virtual power plants. That can also offer ancillary services. Both EVs and RTPVs are connected to the low voltage grid, and they can mitigate the variability of the rooftop generation during the day, as well as store the surplus generation in the electric vehicle batteries and pump it back during the peak hours. And microgrids, smart microgrids, the large buildings and campuses may be converted as smart microgrids, and that can island from the main grid whenever required. The building campuses with rooftop solar and V2G vehicle to grid capability. They can be converted as smart grid connected microgrids, smart grid connected microgrids that have grid interactive and islanded capability. Such microgrids can buy green electricity from the grid at a cheapest rate and store it in the batteries and electric vehicles and use it during the peak hours. So that is a smart microgrid, one solution that we are also experimenting with. And the promotion of dynamic energy markets and peer-to-peer trading, which when talked about in India, India Smart Grid Forum has also implemented 2 pilots with the Australian technology called blockchain technology provider Palage, and is working on one more in a different state. And post completion of these 2 projects, which were conducted in a regulatory sandbox environment, we have given our recommendation to the regulator for further scaling up of the projects, where one of the state regulator has already approved a large scale rollout in the state. And lastly, I would now be talking about the grid interactive buildings, which I will talk about in the next slides. So a grid interactive building, in most of the countries, building sector accounts for a huge amount. We've already heard about that, and it is the field that has a major potential for improving energy efficiency and contributing in the reduction of the emissions. Buildings can serve as energy assets, providing load management or energy efficiency services and generating electricity on site, with owners and occupants who are participating in programs, the demand side management programs of the utility. And further, most distributed generation poses a few constraints on the electricity that consumers export to the grid when on-site energy production exceeds the consumption. So with new technologies, we can monitor and communicate building operating conditions and coordinate control of the loads and multiple distributed energy resources that we have. So
Reena, sorry to interrupt. If you could wrap up so that we have still a bit time left for questions. It's super interesting, super complete presentation, but I still would like to have some time for questions.
Thank you for prompting me. I'll be a little fast now. So the future that we are looking at is that both residential commercial buildings will continuously manage loads and distributed energy resource to better serve the needs of the building. Owners and occupants and electric utility systems and regional grids, and therefore the future buildings that we are looking at will be grid interactive and intelligent and could provide flexibility to the grid. The buildings have own electricity generation resources and energy storage systems, electric vehicle charging points, vehicle to grid functionalities, and could integrate the electric vehicles to the building and the grid, and which presently the building management system in the buildings, they control the HVAC systems, lighting and others, but they don't connect the rooftop systems, energy storage systems, or EVs together. The battery management system of the building may be integrated with the SCADA distribution management system of the utility to make buildings grid interactive, and the intelligent and grid interactive buildings could respond to signals from the utility, reduce their load, increase load, and island from the grid. So these are some of the features I've listed, and other speakers have already talked about it, so I'm going to skip this. Some of the benefits I've already touched upon, that the benefits that we can get with the intelligent grid interactive buildings, it can provide support in energy charge reduction, demand charge reduction, peer-to-peer possibilities can be seen with surplus stored electricity. We can give incentives for demand response programs. It can also work as an ancillary service for managing the frequency regulation and voltage support, and we can bring a lot of resiliency into the power systems with grid interactive buildings. So this is my last slide, and just like to take a few minutes to talk about the key takeaways from my slide. So lastly, I would like to reiterate that in the current scenario, utilities distribution management systems, they don't talk to the building management system. That is the way it is. And we have tried different solutions of bringing flexibility in, through buildings, but as an integrated holistic solution, we still have to have a program in place, a project in place for that. Utilities who are working on, they're only working with demand response aggregators right now, and instead we would want to see a future where they work as a complete integrator, and integration through battery management systems are required with the utility distribution management system. So for efficiently managing a large number of distributed energy sources connected to the grid, it is essential that the distributed energy resource management systems are in place. This is a platform that enables integration and management of distributed resources such as renewable energy sources and battery systems, energy storage systems, electric vehicles, and the loads at the customer premises, participating in the distribution demand response programs. And with this platform terms, we should come, it should come in as an intermediate platform between the BMS, battery building management system, and the distribution management system of the utility, the SCADA DMS of the utility, so that the entire building is integrated with the utility systems. All the resources within the building, including the load which can be controlled, such as EVs, batteries, etc., and rooftop and other distribution resources in the building, storage system, thermal, etc., are connected, and all those can be managed by this platform.